Hello, this is Mr. Collier, and today we're going to be looking at Spearman's rank correlation coefficient. Okay, so Spearman's rank correlation coefficient, sometimes we use R subscript S, sometimes we use the Greek letter rho to indicate it. It's used to assess how well a relationship between two variables is monotonic. As one increases, the other, that should be increases, or as one increases, the other decreases. So this is monotonic positive, monotonic negative. Okay? So it's sort of similar to Pearson's correlation coefficient, but there's some differences we'll talk about in a second. So actually Spearman's correlation between two variables is equal to the Pearson correlation between the rank values of the two variables, which I'll show you what I mean in a second. It's very useful for relationships that are nonlinear, and you also get a number that ranges from -1 to 1, just like Pearson's correlation coefficient. Okay, let's take a look at a couple graphs first. Now let's look at this one on the right here first. So if you try to fit this with the best fitting line, it might look something like this. And Pearson's correlation coefficient minimizes the squares of the distances from the line to these points, right? So you're not going to get a perfect Pearson's correlation coefficient. But if you look at it closely, you will see that for every single point, it's the function's increasing. Okay, so for every single point, it's increasing, so it's always going up. Okay, so that will give you a Spearman's correlation of 1. So that indicates that this function is always increasing. Or in other words, as x increases, the y value always increases. So that's what Spearman's correlation measures. And so one advantage of Spearman's correlation coefficient is that you can use it for a nonlinear relationship like this, which is clearly increasing. Okay. Also, check out the graph on the left. You look at just these cluster dots here and ignore these outliers. You see this looks like a very strong correlation. Okay, it looks like 0.8, somewhere between 0.8 and 0.9. But these outliers are greatly affect the Pearson's correlation coefficient because they're used in the calculation. And so they bring it down to what looks like a moderate correlation, 0.67. Okay, but using the Spearman's correlation coefficient, you get 0.84, which is more indicative of what we see when we look at the scatter graph right here. Okay, so Spearman's correlation is less sensitive to outliers, and it can be used for nonlinear relationships. Okay, so those are two of the very important uses of Spearman's correlation coefficient. So now let's see how it works. So here we have some data. We have, it's not a percent, it's per 1,000 adults with no qualifications. And here we have unemployment. So we expect some sort of relationship between unemployment and number of adults with no qualifications. Okay, so we can use this data here and type it into a spreadsheet or a calculator and get Pearson's product moment correlation coefficient. Or we can do Spearman's. And Spearman's involves getting the rank. So what you do is you start with the smallest value in this set, which is 1. And I'll give it a rank of 1. And then I'm going to go to the second smallest. So you got to be very careful not to miss one. Oh, I did miss one. That is not 1. 1 is at 67, so this one here is 2. And then we can look for 3, so there's no more than 60s. Next highest one is 89, so I'll give that a rank of 3. Then I got 90, actually I got 90 down here, so I'll give that a 4. Then 5, and so on. So we're 6. 6 is at 107. Then number 7 is at 118, and number 8 is at 148. Number 8. Now when we get to number 9, we'll see that there's two 151s. So when you have a tie, you find an average of the ranks. So we're at 8th right now. This should be 9th and 10th. 9th and 10th place. So we take the average of 9 and 10, which is 9.5. Okay, if there were 3 values with a tie, then we take the average of those 3 values. Okay, so these are both 9.5. We assign them 9.5. And then because we just went through the 9th place and the 10th place, or what was supposed to be the 9th, 10th, and the 10th place. Next after that is 11th place, so it's not 10th after that. We should go straight to 11th place, which is 156 is 11th place. And then you go on and you do 12th, 13th, 14th. There's no more ties here, so it's pretty straightforward after that. You go all the way up to 19th place because there's 19 data values. You do the same thing with the other set of data here. So smallest one here is 49. So we'll start with a 1. Okay, then our next data value after that is going to be 66. Our next rank is 2 here. Then next one we have 82 and 82. We have a tie. So that would be 3rd and 4th place. So we get the average of 3 and 4, which is 3.5. So those both get a rank of 3.5. Then the next value is going to be 5th place because we just went through 3rd and 4th place. Now we're going to go to 5th place, which is 84. Okay, so you continue on all the way until you get to 19th place. So let me just fill in a couple more values here. So that means, this place here has rank R1 is 9.5, and then rank R2 is 12. So if you type in these numbers in black, like into a calculator, you'll get Pearson's product moment correlation coefficient. If you type in the numbers in blue and get the Pearson's coefficient for the blue numbers, what you get is the coefficient for the ranks, which is the Spearman's rank correlation coefficient. So let me show you that on a TID4. You can go to Stat, Edit. You can type in the ranks here in L1 and L2. Make sure you go to Mode and make sure Stat Diagnostic is on. And then you go to Stat, Calc, and number 4 is linear regression, right? So make sure there's nothing in frequency list. Make sure you just have L1 and L2 here for X and Y list. Press enter a bunch of times, and here you get here you get the R value of 0.748. You get 0.748. So RS is 0.748. So it's pretty close to a strong correlation. I probably would say that's a strong correlation. Okay, so as the number of adults with no qualifications increases, the unemployment rate also increases because it's a positive correlation. And of course you had a negative correlation. That means as one increases, the other would decrease. Okay, so we're going to do the same thing now in autograph. So let's take a look at autograph. So here is a plot of all the data points. Okay, and if you double click, well, first of all, to enter it, you can just click on this thing here and you can copy and paste or type in all the data. I've got all the data typed in already. And when you type in all the data, before you click OK, you can click on this box called Show Statistics. And then you get a statistics box with a bunch of relevant statistics, and you can see we have the correlation coefficient, that's Pearson's right here, is 0.855, and the Spearman's rank coefficient is 0.748.